Okay. So now we're looking at projectiles. This is the last part of kinematics. This is not difficult, right? But provided you follow what's going on. Okay. So they tell you that the objective and the overview of this, at the end of the unit, you should be able to analytically solve problems that deal with projectiles that's launched vertically or at an angle other than 90 degrees to the horizontal. So, when a projectile is fired, gravity will always influence vertical motion. What does that mean? Right? Just say this is your projectile, it's a ball. Right? You throw this ball up. You throw this ball up, right? What's going to happen to the ball?
Come down.
How does it come back down?
Because the gravity is going to pull it down.
Right? Gravity is acting against it.
Yeah.
Okay? So it will probably go for a motion, something like that. Agree?
Sure.
Okay, fine. Then they tell you that the motion formulas can be used to solve these types of problems. For example, at a maximum turning point, the volume will be 0. What does this mean?
Stops.
So, you see at the highest point that this goes to, right? When it starts to change its direction from going up to coming down, is it moving at any speed?
No, it stops.
It's not moving at any speed, right? Because gravity would have taken, just say you threw this at velocity equal to 10 meters per second up, right? As you go up, obviously it's going to go maybe 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Then it will come back the other way, building up speed using gravity. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We understand that? Okay. So what that basically means, at your maximum height, the velocity is equal to 0 meters per second. Okay, we're cool with that. Okay, cool. Also, the time taken to reach the maximum height would be what? Half of the entire distance that it was traveled. Because can we agree that when it reaches its maximum point, that is the halfway point, because it's going to come down with the same velocity that it went up with, because it is decelerating going up, but it's coming back with gravity pushing it down. Right? This is the exact halfway point.
Yeah.
Okay. So this here is equal to half the time taken to cover the full distance. Okay. Okay.
Is that always the case?
Yeah. In an ideal circumstance, without any other outside factors acting on it, wind pushing it down, gravity, it's just that. Okay? Right. For vertical motion, that depends on only gravity. The following formulas are applicable. So this is vertical. This is only vertical motion, right? We only throw it straight up. Whenever throw it at an angle, we'll be introducing horizontal motion. Can I take this out? Because I'll show you the formulas. Right? Can keep that there, right? Okay, so the formulas that we use. What's the page? Okay, so these are the formulas you use, right? Gravity is equal to velocity minus initial velocity all over time. Velocity is equal to initial velocity plus gravity times time. Displacement is equal to initial velocity time plus time squared. Displacement is equal to velocity squared all over times gravity. Displacement is equal to initial. Right. What do each of these factors mean?
Are these all given in the data sheet?
Yeah.
So we don't have to remember this.
Yeah, this one's argument. I'll double check that, right? Okay. So, what does these symbols mean? Where V is equal to your final velocity. U is equal to your initial. T is equal to time. S is equal to displacement or height. So displacement will be applicable to your x-axis or your horizontal component, right? Height will be applicable to your vertical component or your y-axis. Okay, so I'll just say over here.
It's okay, man.
It is?
Yeah.
Okay, cool. Right? And then G is equal to gravitational acceleration. And who knows what's the value of gravitational acceleration? 9.81, right? But remember, this value is applicable to how you're taking your directions, because gravity acts in what direction?
Down 12%
Down,
of
right?
the
If you took in your question up as positive, what would be the value of your gravitational acceleration? Minus 9.81, right? Don't confuse yourself with that. And I'll just take that up.
Yeah.
I'm just gonna get a sweet with you there.
You have this lecture. You sure?
Yeah.
So these are all applicable to vertical displacement.
And horizontal, but I'm going to show you when we get to that part, right? The only thing that will change is your how you get these values, the initial and final velocity, because you know how we broke it up into its components before?
Similar.
Vertical component is applicable to vertical motion, horizontal component is applicable to horizontal motion. Understand, right? When you're done taking this one, let me know. Okay. You raise the back. There. Okay, I'm not going to take the formulas out because I want to show you how you will use which formula to answer a question. Okay, so let's look at example 1.12. Okay, so they tell you that a projectile is projected vertically upwards at a velocity of 160 meters per second. So this is your projectile. It was projected upwards, so we know that its motion is going to go somewhere again. Right? The initial velocity that was given to us was equal to 160
meters per second.
160 meters per second. So in this instance here, I'm going to take up as positive, down as negative. Right? Right. What value will we always know with every question in this that we work on?
Initial.
Yeah?
Oh.
Gravitational acceleration. Right? Because it's a constant throughout. So you can write it down. We'll say your gravitational acceleration will be equal to what? What is it? Minus 9.8, right? Because down is negative, gravity acts in a downwards direction. So this will be minus 9.81 meters per second squared. Now, how do we answer this question? Okay, this is how you would do it. So what's the question?
Maximum height.
Calculate the maximum height that it would reach. So for A, they want you to work out the maximum height. From what they told you, what do you know? What's your final velocity?
Zero.
Why? Because maximum height. And we said that maximum height velocity is equal to 0. So we know that the velocity is equal to 0 meters per second. They want you to work out the maximum height. That will be your S. Okay? So you would go to the formulas that have S's in them. And you would start to tick the values that you know. Okay? So we know initial velocity here, yes? Do we know the time?
No.
Do we know the gravitational constant?
Yes.
Do we know the time?
No.
We're trying to solve for that. Instantly this is out because there's 4 values here, 2 unknown, there's 2 unknowns.
Yeah.
Okay.
That's,
Here,
that's right.
we're trying to work this out. Do we know the final velocity?
Yep.
Do we know the initial velocity?
Yep.
Do we know the gravity?
Yep.
Okay, we can't use that formula. Let's see for the last formula. Do we know the initial velocity?
Yep.
Do we know the final velocity? Gravitational constant? Time?
No.
No. So which formula would we use? That formula. Right? So you would say displacement is equal to final velocity minus initial velocity all over 2 times your gravity. This would be equal to 0 square minus 160 square all over 2 times
9.8.
minus
Minus 9.8.
9.81, right? Minus 9.81. And what you?
160. 160.
I'm asking to be on 4.791 meters.
You just don't use a calculator. You got a calculator, right? That there.
It's 1,304.
What? Give me more.
0.791.
1,791.
Okay.
That's not like massive.
Because it's displacement, what will the units be?
It's gonna be negative.
No.
Oh no, it's positive.
Oh, it's positive. I mean, how is it?
No.
Remember that?
You
Yes, the minus is here.
This here will become 0.
Minus
Right?
was considered.
This value here would become a negative value. This one over here will also be a negative value. So you just cancel. What's your unit set?
Meters.
Meters, right? Because it's height.
That's right. Yeah.
So that's that. Okay? Then you go to your data sheet or whatever. So this would be on your data sheet. You use your pencil, you'll tick. Right? Right. Let's look at the next one. Last section. The time taken to reach the maximum height. So now they want the time. Now what new information do we know?
We know the distance, the S, the height. Yeah.
We know the S value, okay? So, using this formula here, do we know gravity?
Yep.
Final velocity?
Yep.
Yes.
Initial velocity?
Yep.
We can work out time. This one, we know final velocity?
Yep.
Initial?
Yep. Yep.
We can work out time. This one?
Yes.
This is basically the same thing as that, just rearranged. Okay?
Yeah.
This here, we know the distance, initial,
Yeah.
time we can work on, gravity we know, I mean time is what we're working on, time is what we're working on. Here we know displacement, final, initial, that has nothing to do with time, right? And then here, we know displacement, initial, final, gravity. Right? So you can use any one. But you would use the second one because it is easier to use, it's easier to work with. Also, why I would also choose the second one. You see these ones here, you got displacement, displacement, displacement. Right? What happens in the event that you made a mistake in this one? And you carry that same value into this next question using either of these formulas, you're going to end up losing marks, right? So you rather stick with what's safe for you because they give you the value. Okay? So you'll say velocity is equal to u plus gt. Your final velocity is 0 because we're working time taken to reach maximum height. Equal to initial plus
-9.81 times 10.
You take this across, so be minus 160 equal to minus 9.81 t. You divide by this.
And you get 16.3. I use a calculator.
You understand that's what you do.
Yes, the answer is I use a calculator.
Right? And then when you put that in your calculator, you get
16.3.
16, that's all.
309.
Yeah, 16.30310. 16.310.
Okay, what's the units?
It's seconds.
Why is it seconds?
Because it's time.
Can you see what they gave you over here? Meters per second, meters per second.
Yeah.
Everything was in the correct units. Okay? You see seconds, time, such. Right?
So when we take 9.8 this side, we also put negative.
When you
When you divide, you don't.
Divide now.
I'm dividing. I'm dividing by this entire portion.
Oh, okay.
Right? Not bad.
This is easy. This is easier than the previous one.
It seems easy so far. Anything else?
No, it is as long as you understand what like how the other one, if you understand what the question is asking you,
Yeah.
you go to these formulas, you tick.
But question now. There's no things with angles and all that.
The next one.
What's this question? Are you talking about the question?
Ish.
Yes.
I can look at that. Don't be finished.
Can anybody take a picture?
We can work around.
Angles, angles.
Numbers meaning 60 right?
That's right. In fact, sure.
Yeah.
See, I can't take the picture. Trevor is blocking.
No, that's why he is taking the
I used
photo.
Return.
As a question, when something does go up, right? The initial speed, does it guarantee to come out at the same speed?
No. In an ideal circumstance, it would, right?
He's rubbing
But
off on you.
remember when it's coming back down, if there is like other forces that act on it, like for
Yeah.
example wind or something like that,
Yeah.
it's gonna make you faster. But in an ideal circumstance, because it is acting at a constant acceleration,
Yeah.
when it's going up, it's at a constant deceleration of 9.81 meters per second squared.
Oh,
When it's coming back down,
yeah,
it's
yeah,
at a
sure.
constant acceleration of 9.81. So in an ideal circumstance, if only gravity acts on it, it will go up and come down
Same.
with the same velocity but different directions.
Oh, okay.
Right?
Alright.
Okay.
So far, it's the first time I'm enjoying this.
And that's not helpful, you know. But I told you, kinematics is one of the,
No, this I'm
More
enjoying this-
difficult,
I'm enjoying this part so far.
well, not kinematic, the relative and resulted. Okay. Example.
This one.
Okay. So they tell you that a projectile is directed at an angle. So this is your projectile, it's directed at an angle. 45 degrees to the horizontal. So at this point here, it's 45 degrees to the horizontal. And projected at a velocity of 160 meters per second.
Yes.
Meters per second. Okay? Calculate the maximum height it will reach and calculate the displacement. Okay? So we know that it'll basically take a motion like that. Right?
Yeah.
Okay. Let me draw our axis. Let's try this. Now remember I told you that the vertical component is associated with maximum height, the horizontal component is associated with maximum distance or displacement. Yes? Okay. So when we're doing maximum height, what will we be using? What component?
Meters.
Gravity?
What that?
No. So I'm saying
Y-axis.
yeah, y-axis, right? Which is your vertical component. So this here is your vertical component. This here is your horizontal component. How would you get this value? And how would you get that value?
So you have to use your sine inverse.
Exactly that. How would you use it?
So your first time we went.
Tell me what you would do.
One
Oh, okay, so you
60.
For which one?
So first you have to say positive, negative, huh?
Yes.
So
So I'm
positive is
taking
up.
up as positive, east as positive, down as negative,
Yeah.
west as negative. Right? So remember now we got two sets of axes in that angle. Okay.
Your
Nice.
vertical component.
What your vertical component should be equal to?
160.
Remember your vertical component.
Sine
If you draw it parallel here,
45.
that's a 90 degree. This is also your vertical component.
Yes.
Okay, so whatever this is equal to, that will be equal to the same thing. Okay? How would you work it?
So vertical component 160.
So you'd say this is equal to,
160.
so we'll just say the velocity of that, then
Sine
Sine
angle.
45.
the angle. Okay? And then here,
Cos.
the velocity, cos,
Angle.
angle. Cool. Right? We there. Everybody understands that? Any confusion?
So we're going back to what we were doing before.
But it's only for this part here because vertical component is associated with maximum height or height. Horizontal component is associated with displacement. Okay. Now, for question A, they asked you to work out the maximum height. To work out the maximum height, we need to know the magnitude of the vertical component. So we would say the vertical component is equal to the velocity sine of your angle. The velocity will be what?
160.
Positive 160, right? Because remember when you break it up, it's moving northerly. Okay. 160 sine of. Could you get?
113.
137.
137.
This will be.
meters per second.
What did we just work out?
The maximum height.
No.
Oh, sorry, the initial velocity, sorry.
The initial velocity,
Yeah.
right?
Yeah.
This is your initial velocity that we will use to work out our maximum height. Okay? So this value here is the initial velocity, which is equal to 113.137 meters per second. Right? What else do we know? What other information is always given to us?
Gravity.
Gravity. Okay? Gravity will be equal to what?
Minus 9.81.
Right? So okay, I'll raise it here to that. So we know this. We know that gravity is equal to minus 9.81 meters per second squared. What else do we know? What is the question?
The maximum height. So your final velocity is 0.
Right. Okay. So now your final velocity is 0 meters per second. Do we all understand how we got this information?
Yeah.
Yes.
That now that we have, this is all the information that was given to us, and we'll rework that out. Okay. Now we will see which formula we can use to work out your displacement.
So you want S.
So we're looking at the formulas for S. We know initial velocity, yes? Do we know the time? Do we know gravity?
Yeah.
Here, do we know final velocity?
Yes.
Initial?
Yes.
Gravity?
Yeah.
Here, initial?
Yeah.
Velocity?
Yeah.
Gravity?
Yeah. No.
Time? No. So which formula can we only use? That one. Okay? So, I'm just gonna write here, right? Okay, so S is equal to V squared minus U squared all over 2 times gravity. Your final velocity is 0. Right? Minus your initial velocity is,
113.1.
it's going to be that value, right? 113.137 all squared divided by
3 times minus
Minus.
minus 9.81 which is equal to, don't read it from the textbook. You've got the calculator in front of you. Probably in the paper when you're doing it, you're going to be stunned with something simple like this because you're not practicing it.
Six 652.394.
652.394 5 meters. That's your maximum height. Was that difficult? No, right? All you needed to know was when they asked for maximum height, you needed to break this line up into its vertical component. Using that vertical component, that will become your initial velocity. Then we know gravity, because you're working with maximum height, velocity, final velocity is always going to be 0. You went to your formulas, you saw what you could have used, and then you worked out your displacement. Anybody confused?
There's a question, right?
Right.
I'm feeling that's nothing. But would they maybe ask us ever, not necessarily if your final velocity is 0, would they ask us, like let's just say if your for calculation the velocity was 10 meters per second. It should, on the final, it should say the final technical final velocity will be 10 meters per second, right? What height has it traveled? Would they ask us like partially?
Yeah.
Ask us that.
In the activity 1.14, they ask you calculate the final velocity after 50 meters if the projectile is fired vertically. I think it's question.
So they could play around
C.
with what they want.
Exactly.
So it'll be
And this is still easing into it. Example 1.14 is more the type of questions that they will ask, right? Okay. Are we cool? Right? Cool. Can I take this? I don't like writing on that part because you can't see it very clearly. Can I take a picture? Did you get?
Yeah.
Okay. No, I'm not taking that out. Taking this. Okay. Next question, they want the displacement. So they're looking at basically how far did he go from the start point till when he hit the ground again. Right? What did I tell you? Displacement is associated with your
time.
like how I said maximum height is associated with your vertical component.
Yeah.
Oh, you can horizontal.
It will be your horizontal component. So we're gonna work that out, right? We're gonna say your horizontal component is equal to the velocity cos of your angle. This would be positive 160, right? Because it's moving in a easterly direction.
Sorry,
Yeah.
I'm a bit confused.
What?
So so we got two questions. They're asking for maximum height, we're
Which we
using
worked
the S, which is on your vertical component. If they ask for displacement now, it's always going to be on the
Yeah, the distance, the x-axis.
x-axis.
Don't mix up displacement and height.
Displacement and height is different, right?
Yeah.
Displacement x, height will be
Y-axis.
Okay, that, when I wrote it down, I said where I wrote below it, right? Okay, so this would be cos of 45. So this value was the same as the last one, it is 130 meters per second. Everybody's okay with how we got to this.
Because it's 45 degrees.
Right?
yeah, probably
No, I'm saying, but everybody's okay with how we got to this horizontal component.
Yeah.
Right? What value? Honestly?
That's B.
Okay, that's it. Right. Well, what did we just work out?
Your initial, your U.
Your initial velocity along your x-axis. Okay? So,
U.
this here is u equal to 113.137 meters per second. What else do we know?
You know the final velocity.
How we know?
No, we don't know.
The final velocity we know.
That's all.
We know gravity.
We know gravity,
Yeah.
right? Gravity will be equal to what?
9.8.
Minus 9.81 meters per second squared. What else do we know?
Yeah, that's all.
We worked out the maximum height already. No, we don't need
Yeah, I don't need. So we only know that.
We don't know anything else.
Yeah,
Right?
only those two.
So now, how do we solve this question? Okay? This is how you would solve the question. Okay, let's try it. Yeah.
Why are we looking?
It's something I told you earlier on that you would apply now.
So half the time.
Half the time gives you what?
Half that.
To point to your maximum height.
Exactly. Right? Remember something, right? The time taken, I'm just going to say this is my maximum height, right? The time taken to reach your maximum height is half the time taken to reach your full displacement. Do you understand what I'm saying? Okay? It's half the time taken to reach your full displacement. Okay? So what do we need to do?
Work out the time.
Work out the time.
Time.
But what would we use?
So we got the initial velocity, we have gravity.
We won't use this stuff. What is the time? This time here, we're trying to work out that term. What is it associated with? This time coming up here is what?
We already worked out the height. So.
We worked out the height, right?
Right.
We need to use the height to work out the
time.
time. Yes. Okay. So using that there, let me take out my cheeks again. Are you with me?
So can you go back to that thing? It said the maximum height is half what?
So I'll write it down there. The time taken to reach maximum height
It's half G.
is half the time taken to reach the full displacement. You understand that?
Okay.
Everybody understands, right?
Yeah.
Okay. So using the values we had for our maximum height, we're going to work out the time that it took to actually reach that maximum height. Okay.
Okay.
Right. In terms of the maximum height stuff, we knew the final velocity, we knew the initial velocity, we knew gravity,
We didn't have time.
time,
No.
we can work it out.
Yeah.
But we can work it out. Okay? So let's use, did I use that formula? Yeah. Let's use that formula, right? Or you want to see for the other ones, you can use that one as well. It's fine. Okay, let's just check.
That's the easiest one.
Yeah.
Yeah.
The other
Then
one's
if you
for
can always use
displacement.
it, use that one, okay?
See, the other one's got displacement, so you don't need.
Yeah.
Yeah.
So your maximum, not maximum, let's say your velocity on your vertical component, right, is equal to your initial velocity on your vertical component plus gravity times 10. What are the values?
Zero. No, that one is zero.
That's zero,
That's
right?
zero.
Vertical
V is
component,
zero.
maximum height,
Zero.
right? I shouldn't have taken out the last question.
Yeah.
Right? 0
is
equal to
160.
160.
113.
113.
113.
Your initial.
No.
It's not this 113.
No.
It's the vertical component
Yeah.
113. Because I don't want them
Bring the height.
to ever give you a different angle,
It's
right?
gonna give me the
160.
160.
Yeah,
160,
but-
not 113.
Because
It
of
is
the
113.
Initial question.
No, because
Because you're using the vertical component to work out vertical component stuff.
Okay.
And then you're using horizontal, the velocity along your horizontal line to work out horizontal component stuff.
Oh, you don't
it's the same because of the
But it's same because of the 45. But I don't want you to think that I'm using this value. I'm not using the horizontal component velocity.
Yeah.
If they gave you 50 degrees or
Then
something,
it would be
right? The value is obviously going to be different.
Yeah.
So this value here, initial velocity along your vertical component. Okay? So this is 113.137 plus
minus 9.
minus 9.81 times 10. This you take it across, minus 113.137 equal to minus 9.81 times 10. Right? You're going to divide this 113.137 divided by minus 9.81 will give you your time.
11.533.
11.5
533.
seconds is equal to time. What time is this?
Full time. No, that's half time.
So after time, it's
Yes.
time taken to go from to.
This is the
to
time.
It's a half, this is the
Taken to reach maximum height. So the time taken to reach full displacement will be equal to what? 2 times 11.533, which is
23.06.
23 seconds.
Yeah.
Right. Now let's go back to the values we have. Now we also have time. Because now we know time is equal to 23.066 seconds. Okay, so if I take this out, they want us to work on the displacement. These are our displacement formulas. We know our initial velocity.
Yes.
We know time.
Yes.
We know gravity.
Yes.
Time?
Yes.
Yeah, we know final velocity.
Yes.
No, we
No, we
We don't know. Right? We don't know final velocity. We know initial, we know gravity. Yeah. Initial,
Yes.
final?
No.
Right? So okay, that's out. So we're obviously gonna use that formula. Okay? So we're gonna say therefore S is equal to UT plus half GT squared. Substituting your values, your initial velocity is 113.137 times 23.066 plus half times minus 9.81, 23.066 squared. Watch again.
The final velocity we don't know,
Because along the x-axis. Then
yeah, I think that's fine.
you don't have these calculators. You see my zero from answers.
That's why I asked you guys for it. Let's go calculate it.
Oh. Okay. Somebody.
So waiting someone.
Seven point one three.
Everybody else get that? Can I say?
Oh, no. I see where that dropped. That wasn't the right answer.
Minus 0.0399.
Can't be.
How do you get minus?
That's what I said.
Yeah, I'm also wondering how it's coming to minus. But see, they used a different formula when they were working it out. They just said the displacement is equal to VT. You know, like how we worked it out for that other question?
Yeah, but you should have got the same answer.
Yeah, I'm also thinking you should have got the same answer.
Let's try and let me.
No, I got the same thing as
Yeah.
Sheba when you worked it out. Right? Okay, let's do it like how they did it, right? I'm checking this out. So the way they did it was S is equal to V T. Right? This is equal to 13.137 times 23.066, and then that should give you what they are, 2000 something.
2609, 618.
I'm gonna double check this. It's still supposed to give you the same answer regardless. Let's see what I worked out. I used the other formula. Okay, but overall, guys, do you understand the method we use? Right? Yes? No? We worked out the horizontal component to get the initial velocity along the x-axis, right? Then we needed to work out the time taken for it to reach its maximum height and double the time for maximum displacement, right? Using those values and your gravity, and you could have then worked out your, well, you could have worked out your displacement. Oh, you know the problem. Gravity won't act along your x-axis.
So there's no gravity.
There's no gravity in that there. Sorry, guys. Gravity won't act along your x-axis because remember, gravity is vertically downwards. Okay? It's not. There's no components to it itself. So that's why they use that formula. That's why we were having a wrong answer with that. Because right.
So where's that?
Wait, now I have to delete first.
Remember we used that formula when we worked out.
Yeah, but you could have used the same formula, but instead of putting a number on a G, you put a 0, which is equal to 0.
Yeah, so it's the same thing, right? Like if that same formula, right? If you like exactly what he said, right? There's no gravity taking place. So you could have said 0. This entire portion would become 0. So what you left with initial times time, which we have,
Which
is the same thing there.
Yeah,
right?
that's how they got it.
Change that one, yeah. Good work, Emma. Right. Now we could. See, now with the angle it's not so bad.
Yeah.
Not so bad.
Yeah, it's not. I think because this is not 3-dimensional, whereas with the other companies,
Yeah, this one doesn't get.
doesn't get something. Yeah, a lot easier.
So in your exam, they'll test relative velocity, resultant velocity, and projectiles under like question 1. So it'll be 1.1 maybe a relative velocity question, 1.2 maybe a resultant velocity question, 1.3 maybe projectiles.
But then how many marks is this?
Check one of the past papers. But no, in terms of how the weighting is, I think the series covers like 12 overall.
So normally it's 17 marks. I'm looking at 22 hours. No, whether the new ones have changed.
It's probably the syllabus was updated, yeah.
Yeah. So
But remember at the start, the first day, I gave you the percent weightages? Weighting?
Yeah, but
Weightages.
your kinematics is 15%.
So it's 15 marks. Papers are 5. Right? So it's 15 marks.
so you might have 5. Yeah, for the
Right? So far, we 5 marks there.
Got a problem now.
Okay, we got 10 to do this last one. Because once I do this last one, you're basically done with kinematics. Okay.
Ready?
Yeah.
Let's do it. Let's go for it.
Okay, I'm taking this out, eh?
Yeah.
So,
Yeah, go.
Yeah, go for it.
Let's move.
Put it on the group already. Yeah, I think Bill should.
Chema, it's still videoing, eh?
faster.
Yeah.
It's still videoing?
Yeah?
Okay, good.
And we can still
Yeah, like
do
you
it.
said.
How come it's right view, not right button? I don't need to calculate it.
Could you give us wrong answers?
Yeah, you keep getting some answers.
Teach them the book.
I heard the incident about the 6 steps thing.
This guy was fast, man.
I was very disappointed.
But the best part was he was trying to explain
So basically when he walks out the front now and the secretary and she sits in there, she will start laughing and she sees that all your
You see it now, scientific research. No, when he came, so he started laughing because I asked him why we were laughing, right? And he told me, that was so confident. It's 6 steps.
So is that why you had no meeting there?
Yeah. You said no, we have to go back.
That's why I keep speaking class.
You don't have to check. Hey, you're from here. It wasn't even my one,
I was waiting to see timetables. Maybe we need to go back to timetables.
Let's use a calculator. Yes. Okay. Example 1.14. This example is a bit tricky, right? But oh my god.
Now after this one you can go.
Yeah, I know. Thanks, Trevor, for allowing me the opportunity. Right. Okay, so tell you that a cannon is situated on a building 50 meters high. So this is your building. This building is 50 meters, and then you have a cannon. Right? It fires the shell horizontally at at a velocity of 280. So it fires the shell at a velocity of 280 meters per second. So you know it can go something like this. For this example, I would like to take down as positive. Or do you want to stick with our normal?
Say conventional.
Keep it as up. Okay.
Positive, down negative.
So up as positive, down as negative, east as positive, west as negative. So instantly, what would this value become?
So just
What?
your height. So
What would it be? Positive or negative?
Positive.
Why is it positive? The shell is being fired from here.
Oh, it's going down. It's going down. It'll be negative.
So like relative to the shell, it's gonna be 50 meters down.
Yeah.
Right? So that's negative.
Okay.
Okay? And your gravity would be equal to
Minus 9.8.
right. Calculate the time taken until the shell hits the ground. Now how are we gonna work out the time taken until the shell hits the ground? This is the only information we have. Right? Using it, can we work out the time taken? So this is initial velocity. Okay. Using the information we got, can we work out the time taken? Let's check. Do we know final velocity?
No.
Do we know initial?
Yeah.
Do we know gravity?
Yeah.
Why are we trying to work out time? Do we know final? No. Initial?
Yes.
Yes. Gravity?
Yes.
Time. We know displacement.
No.
Well,
Yes, we do height. We know the height.
but that's vertical. It's not your
It's not
horizontal. It's not.
Okay, yeah.
It's not that part. Okay. Right? So we don't know that. We know initial. We want to work out the time. We know gravity.
Yeah.
Here, same story. We don't know final. We can't work it out. Right?
Work on something else.
So, what we would do in this instance is we would use the vertical component of the situation. Right? For the vertical component, what's the vertical component of the shell in terms of its initial velocity?
50 meters, or minus 50 meters.
Velocity.
What's it?
So I
280.
No.
Vertically.
Zero.
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 Right?
It's
Vertically it will be zero because does it have a vertical component?
No.
No. Right? So I'm going to say for vertical motion, your initial velocity is going to be 0 meters per second. Right? Question here. Now what do we know? What else do we know?
your displacement on your vertical.
You know that, right? Because it's vertical, which is equal to
Minus 50.
minus 50. Also, how you would have thought about using it is they don't give you information for nothing. Like this piece of information they gave you is not for nothing. The fact that that building is 50 meters high means you must use it somehow. If you can't figure out where to use, or if you don't know where to use it and you're stuck in a question, 90% of the time, that's probably where you need to use it. Okay? The gravity here is minus 9.81 meters per second squared. Now can we solve it?
Yes.
Right. Do we know final velocity? No. We can't solve that, right? Can't solve that. Here. Do we know displacement?
Yes.
Do we know initial velocity?
Yep.
Do we know time? Okay, that's what I'm trying to work on. Gravity?
Yeah.
Right? Displacement? We don't. We don't know that. We know that. We know that. Okay, so the only formula we can use is
That one.
That one, right? So you're gonna say S is equal to ut plus half gt squared. Your initial velocity is, oh no, your displacement is
Minus 50.
minus 50, your initial velocity,
0.
we're working on time, plus half your gravitational constant,
And
Minus.
9.8.
9.81
time,
square.
we were exactly working on, right?
So it's 50.
So
50
this would be minus 50 equal to, this part here will
0.
fall away, right? Because it's going to be 0. This here would become minus 4.905, 905, right? T squared. Then you're going to divide by this. Yes? You're going to divide by this value. We're making T the subject of the formula, right? So you're going to end up with minus 50 all over minus 4.905 equal to T squared. Right? And then you square root this to get value of T.
3.19b.
What you got? You what's in here?
3.19.
Why are you looking at me? It's awful.
50 divided by 4.9.
Yeah.
What the heck?
3.19.
We worked out the time.
I don't know my calculator.
It's the round here.
So that will be the time to get from day to day.
Yeah. The motion of the shell. Right? Yeah.
So 5.
I think that why you said minus 50.
Because see the shell is here.
Yeah.
Right? The distance from the ground relative to the shell is 50 meters down. So that's why that value would be 50. Okay, good.
Next one, B.
Right. The next one, they ask you to the horizontal displacement of the shell. This is exactly like how we did that last one, but now we know the time taken, right? The time of it. So, using this formula here, gravity will be 0, obviously, right? So your formula will now become displacement is equal to ut. We know initial velocity, which is, now we're back to horizontal.
Yeah, 100
280, 280, right? So it'll be 280 times 3.193. Come on, guys, communicate.
You stand in front of it.
You're supposed to know it by before I'm there. What do they come to? Did I do your calculation?
893.971.
I thought you were going to look at the answer again.
893.
893.971
.971.
meters.
894.
Your also got what you got? 893.
193.
Times 3.913.
Yeah, but I also got what you got?
894.
93.
Why are you getting 894?
Also that. So,
Isn't it 4?
yeah.
Yeah.
0.04.
89404.
9404.
Yeah, 89404.
Now maybe you should use the 3.193. You never use the old.
We used the golden.
I used the whole number.
Or the whole number. That's
Yeah.
right.
Right, what it is?
We
894?
894.04.
Yeah, we rounded off. That's right. Because it was
04, that's all.
3.1.
Yeah.
Okay, that's your answer, right?
Yeah.
Okay,
Just rounded off.
so now they want to know the velocity when it hits the ground. How would we do that? So you know, similarly to how we did like vertical projectile motions.
Yeah,
This is vertical projection motion. How we did resultant velocities. Right? We would have taken this vertical, multiplied by the horizontal, and it would give you like that. Yes? We're going to do something similar here. We're going to work out the velocity of the vertical component, like if you just had to fall,
Yeah.
and we're going to work out the velocity. Well, we actually do know that, right? Okay, so let's work it out, right? Your
So it's gonna be the sign of
let's go for vertical motion, right? So for vertical motion, we know this information, right? We know u is equal to 0. We know displacement is equal to minus 50. You know, gravity is equal to minus 9.81 meters per second. And we know time now because of that. We know time is 3.193 seconds. Right? We want to work on the final velocity of the vertical component. So we know initial velocity, right? We know gravity, we know time. Let's use that formula. Right? So velocity is equal to u plus gt, which is equal to, what is it equal to? What values are we substituting?
280 plus
GT.
But did you just miss
Just a GT.
everything I just said?
It's just a GT.
Guys, I literally wrote these values.
So it's
Yeah.
it's 9.8 times
I wrote this.
3.913.
Y'all looked here and then you didn't worry about this.
It's
Right? What is your
9.8.
initial velocity?
So it's not
Zero.
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 So it's
Right?
9.81
Plus
times 3.193.
positive or negative 9.81.
positive.
Get in the habit of saying what it is.
Okay.
Minus 9.81
Yeah.
times
3.193.
which is equal to
31.323.
what you got?
31.323.
Minus.
Minus 31.323.
Yeah. Minus 31 point
323.
minus 31.323 meters per second. What does the minus mean? It's moving down, right? So it's the same thing as saying 31.323 so,
No.
meters per second,
So,
So,
okay, so.
right? Because it's a negative value, it's moving down. Let's do horizontal motion. Using horizontal motion, right? You see how all of these formulas got gravity, 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 gravity. Right? What's the gravity on your horizontal component?
Zero.
Zero. So if I use this formula, right? Velocity is equal to initial plus gravity times time. What's going to happen to this part?
Okay.
It cancels out.
It's going to fall away. So therefore, your velocity is going to be, your final is going to be equal to your initial velocity. So the velocity in the horizontal component will be equal to 280 meters per second. Okay? Now we use theorem of Pythagoras to work that out. That's fine, right?
So, because ball is falling,
Yeah.
it doesn't reduce speed, it keeps the speed constant.
No, it will because
And
remember
when
it's
lands
moving
here,
like this,
we-
but gravity is pushing it along the vertical axis.
Yeah.
So it's going to be pushing it like that. Okay,
So it'll be the same speed there.
let's see that. So the velocity I said, the final velocity of it will be equal to, let's get the theorem of Pythagoras. It's going to be equal to your vertical component velocity squared plus the horizontal component velocity squared. We all understand, right? Is anybody confused?
Okay.
Yeah, what you're trying to work on.
Oh my god.
We're trying to get that answer for
Oh, yeah,
that,
we need to go.
but we're using the Pythagoras theorem.
Right, and I showed why we're using it, right? So this here would be square root of 31.323 squared plus 280 squared, which is equal to
281.747.
so that's the velocity with which we hit the ground. Do you understand? Is anybody confused?
It's slightly higher.
Because that will be due to the gravity acting on it,
Yeah.
pushing power, that's all, right? Yeah.
No, but I have to finish my sentence also.
Okay, you actually
I'm
got
sorry,
it.
I'm ready.
Okay.
I'm just going to say.
So what you guess?
D, yeah.
Okay.
Student D, D.
Okay, we almost the next two parts are not that long, right? Can I take this off?
Yeah, you can take that one out.
Okay. What's the time?
25.
Okay, I need like 10 minutes. Okay, so the question here now changes to the velocity of the shell after 50 meters if the cannon is fired vertically upwards. So now, this cannon is firing the shell vertically upwards. Right? The initial velocity will be 280 meters per second. The displacement that they gave us is what?
50 meters.
50 meters.
The displacement is equal to 50 meters. Gravity will be equal to, we're taking up as positive, down as negative.
Positive 9.81. No.
Minus
Right? Minus 9.81 meters per second squared.
So this
Is it
This is like the first example we did.
Yeah, but they changed it in the question. But no, but now they asked you to work out what the final velocity is after a certain displacement. So they're asking you like, it's been shot after 50 meters, just say 50 meters is there.
Yeah.
What's the velocity of it?
Okay.
Like, you know, somebody needs to what few answer.
but they're not asking it on the mountain.
No, they changed it. Now they said that the velocity of the shell after the after 50 meters, if the cannon is now fired vertically upwards. Okay. Is that fine?
So you use that.
Yeah.
Is that
Yeah,
fine?
but
Use that equation.
if it's on the mountain, you expect it to come straight back down, so it's
no?
not going to go.
No.
Forget
How will it
about
go
that.
straight back? It's being
In
fired
this case,
at 280 meters per second,
Straight up.
straight up.
no, but in this case, take it as there's no mountain, it's just a flat.
Yeah.
No, but it's a building, guys, not a mountain.
Yeah, forget
Or
about
building or
whatever.
Yeah.
Right?
Forget about that thing.
Yeah, that's why I drew a new diagram for you.
Yeah.
Even if you want to take it, remember something. All this happened is it turned that way, which is that
Because that 50 meters has no effect on the.
on how it's going down.
Yeah.
Okay,
It'll have an effect if you wanted to take, if it was coming down.
and you want
see
to
what
work
the
it
velocity-
final.
Yeah.
right? So we know our initial velocity, right? We know gravity. Do we know time?
No.
No. Do we know displacement?
Yes.
Initial velocity,
Yes.
time.
No.
No. Do we know displacement?
Yes.
Yes.
Initial velocity,
Yes.
Yeah.
gravity.
Yes.
So we can use that, right? So S is equal to V squared minus U squared all over 2 times gravity. Your S value in this case is going to be positive 50 equal to your velocity is what you're trying to work out minus the initial velocity which is 280 squared all over 2 times minus 9.81. So what's going to happen? You're going to take this across. So it's going to become 50 times 2 times minus 9.81 equal to V squared minus 280 squared. What's this number?
Oh yeah, 50 times.
Minus 981.
And then 981.
Minus
981.
981.
981. Allah.
No, just straight.
Straight.
Yeah.
Okay, so you take that across plus 280 squared is equal to V squared. What's that number?
79381.
79381. The square root of that
Two 281.746.
velocity is equal to 281.746 meters per
Seven.
second. Okay, that will be its final velocity. Okay. Next.
Last question. No.
No, how you got the number? I got because it
No, 799.
His number was wrong there.
Which one?
Where are you getting that 79979? I'm getting different things.
Oh,
77419.
yeah. Which one is this?
I'm getting 77419.
Yeah.
Yeah.
Okay, so this here is
Hey. What's wrong with you?
77419.
77419.
That's the wrong mode.
Square root of this. Because okay, you know why this answer doesn't make sense, right? It's being fired upwards at 280. How is it building up speed when gravity is acting against it? Right? So you must check if your answer makes sense, right? Then
278.243.
so this is 278.243.
243.
Right.
Go.
Cool. Okay, another method they used is much longer. Don't use the method, it confuses us, right? This ticking thing is what helps you, you don't get confused, right? Let's just do the last two quickly. Yeah, the number answer.
No, not yet. It is easy to take first.
Nikki, do us a favor.
Right.
Every time he gives us a wrong answer, just pinch him.
He's behaving like Lara.
Okay, so for the video guys, this is question
Approximately
D,
to Lara.
right? This was question D, okay? You're watching the video and you, I don't know.
Ready?
Okay, so what's the question?
The time it will take for the shell to fall freely to a distance of 15 meters. And now it's going down now.
Okay, so what does free falling basically mean?
So it's
Only gravity is acting on it, right? So it's basically this object is being dropped, and it's being dropped for a distance of
50 meters.
50 meters,
So
right?
initial velocity will be
0.
9.8.
It's zero.
Not
The gravitation
Oh,
is
that's-
accelerating according to gravity. Okay? Can we take down as positive because this object is falling, free falling, right? Okay, so down is positive, up as negative. So now in this instance, guys, what would your gravity be?
Plus.
Plus
9.
9.81 meters per second squared. They want us to work on time. Using the information that's given to us, how would we work on time?
We use that SUT plus half GT squared.
This one. Okay. Okay, you guys know why we're using it, right? We know initial velocity, we know gravity, we know it's got 10, or we're working on 10, isn't it?
Working on time.
displacement.
Yeah, we know displacement, right? So,
We use the last one.
why I don't want you to use this one, I think we can also
So we use
use,
the last one.
So, yeah.
You can't use mass.
no, we don't have a final velocity.
You can't use the.
Oh, you got
you can't use the
okay, yeah.
second last one too because you don't have the.
Okay, wait, never mind. I thought this will come to a point, actually, the value is 0. Okay, so this is E. S is equal to UT plus half GT squared, right? This value here will be 50 equal to 0 times 10 plus half
9.1.
minus 9.81
Positive.
positive
Square.
T squared,
Yeah.
right? This will be 50 divided by 4.905 equal to T squared. And then you square root this, and your T will be equal to
Square root of 50 divided by.
put your square root first.
3.193.
3.193 seconds. Understand? Understand, yes?
Yeah.
Understand?
3.913, yeah.
You don't understand which part you don't understand.
Free falling, the signs.
Yeah,
So now you have to change because
because we took down as positive and up as negative. Make a note of this and take me down. So obviously your gravity is acting in downwards direction, right?
That's
So
why we should
this will be
We shall left that up was positive. down
Okay.
was negative.
if I leave it the way we normally do it,
Then you got two negatives and
this will be negative, that should be negative, right? That should be negative,
Just count it's
that should be negative, that should be negative, that should be negative,
Same thing.
and you come to the same answer.
Yeah.
yeah, but it's easier for
Okay, no, I didn't say consistency, but change that. Okay, so last question. The velocity with which it will hit the ground if it were in free fall for 50 meters. So what they want your final velocity. Now we also know the time, which is equal to 3.193 seconds. So we can use, we want to work on this initial gravity time. Let's use that.
Yeah.
Right? F is equal to, velocity is equal to U plus GT. The initial velocity is 0. Your gravity will be equal to minus 9.81, and your time will be equal to 3 31.193.
31.
So you end up with negative 31.3
But now, starting will be
meters
Going
per
south,
second. But what does the negative sign mean? Direction, right? So your answer is actually velocity with which you needed the ground, 31.321 meters per second, down or south.
Okay.
Right. Was this bad?
no.
Yeah.
What?
Can you put a tutorial up for the calculator? How to use
Yeah.
the calculator? You need one.
Register.
Huh?
Register.
It's got the register.
Tutorial how to use.
Did we give us one?
Okay.
Yeah.
Yeah, you did say. Guys, please make sure it's
Yeah.
and try it.
Both of them.
Okay, guys. So your activity, your homework is activity 1.4.
Please take it down for me, guys. I have to leave. Thank you. See you all. Have a good
Okay.
weekend. Thanks, guys.
1.4, question 1, question 2. Right. Also, guys, you all will see that after the section on page 27 and 28, they give you a summary of the formulas we use for each section. Go through it, eh?
Yeah.
So that brings us to the end of module 1, which is kinematics. Does anybody have any questions on what we
Signed.
did?
We all signed.
2, 4, 6, 8.
There's 9 at last. Someone can say.
Okay, Bilal, you signed, Mal,
No.
you signed.
4, 6,
What did you
8.
decide?
No, give me one side. Give me one side.
Which one?
Give me one side.
Like I might teach tomorrow, right?
Activity 1.4.
Activity 1.4, it's 1.4, isn't it?
Yeah, he said activity 1.4.
Question
1 and 2.
25. Page 25.
Page 26, when
25.
continued. Okay. Activity
Question 1 and question 2.
Yeah.
And on page 27, I was saying, we got a summary of the section in terms of the formulas we covered for relative velocity, resultant velocity. Go through it. It's helpful, right?
Hold on. Read page 27.
Yeah. Okay, so that brings us to the end of kinematics. Does anybody have any questions?
Which numbers you said? 1?
Question 1 and 2.
That's due by Thursday, yeah?
Yeah.
Yeah.
And Friday we
Yeah, Friday.
holiday, yeah?
Okay.
Then are we the extra day thing, you're still gonna come back on that?
Yeah, we just need to